I'll be giving you a brief introduction on balancing equations, predicting equations, and writing net ionic equations. Let's begin.
Now, for our first equation, we have a synthesis reaction. Quite a fine reaction, if I do say so myself. Start off, nitrogen, we add hydrogen to make NH3. Alright, now, what we need to do when we balance an equation is make all these values the same because of the law of conservation of matter. You see, it states that we cannot have 2 over here and only 1 up there, and that's why we balance equations. To start off, we're going to make this 2. Now we have 2 nitrogens, 6 hydrogens. Since the nitrogens match, we'll just put 1 there, so it's the same value. But the hydrogen values do not match. So we need to put a 3 in front of the hydrogen, because 3 times 2 is 6, 2 times 3 is 6, and all the values are now the same. Now, for problem number 2, we have a complex combustion reaction. We start off C8H18. We add to that some oxygen in order to make CO2, carbon dioxide, plus water. Alright, we're going to start by balancing the carbons first. So since there's 8 here, we're going to put 8 here also. Now, we're going to balance the hydrogens. There's 18 here, so we're going to do 9 times 2 to equal 18. Put a 9 right here. Alright, the only problem with this is, if we have 9 oxygens, that's going to be an odd number. And the only way to get, to balance the oxygens is if we have an even number because of this 2 right here. So we're going to have to double everything. So we'll multiply this by 2, making 16 carbons, 36 hydrogens. Multiply this by 2, get 16 carbon dioxide, and 18 water. Now, when we add this all up, we have 32 oxygens, 18 oxygens, added together equals 50. So, 50 divided by 2 is 25. Oh man. Dear God. Excuse my poor handwriting. Alright. This is everything. It's all balanced. Ta-da! Now we will predict an equation. First we'll start off with our double replacement reaction between sodium bromide and calcium fluoride. Alright, when you're predicting an equation, you look at your sheet for guidelines for predicting the products of selected types of chemical reactions. You go down, see it's a double replacement reaction, and you match it up with the type of double replacement reaction. From this, you'll be able to see that you swap the cations and anions to form sodium fluoride and calcium bromide. And that's all there is to predicting equations. Now, of course, we have to balance this just like any other equation. And we see that there are 1 here, 2 there. So we will multiply this by 2. 2 fluorides, 1 fluoride, multiply this by 2. 1 of each, and your equation is balanced. Alright. Now we are going to learn how to write a net ionic equation. We've already figured out that the precipitate in this equation is Ca3PO4 because we looked at our sheet and followed the guidelines and found out that this is the insoluble portion of the solution. Alright, what we're going to do in a net ionic equation is we're going to remove all the spectators from the equation and only put in the cation and anion that form the precipitate. So first we're going to write 3Ca and put the charge to it, which is 2 positive. Now we're going to take the anion and add that to it also. And the charge of this is 3 minus. When we react these to form C3PO42. And that's how you write an anionic equation.